All right, this video is going to talk about access control lists. Access control lists, as we will be writing them, are going to kind of work at the network layer and the transport layer. We'll be looking at network layer, IP addresses. We'll be looking at the transport layer ports that are going to be used, and we'll also look at some other protocols such as ICMP. So kind of a layer 3, layer 4 kind of thing. Next generation firewalls, they're called lots of times, can actually look up into the application layer and make decisions based on that. But we're not going to be doing any of that in this class or this lab. We're basically just going to be filtering based on ports and protocols and IP addresses. So that's what we'll be doing. Access control list. There are many uses for ACLs, not just for filtering traffic. They can be used for matching traffic for NAT, as you should have seen in the NAT materials we were supposed to cover. You can also match traffic for VPNs or quality of service. All routers and firewalls have some mechanism for filtering traffic. When I say access control list, we're talking specifically about Cisco routers and how we do it on that, because that is what we will be doing in the lab. But you should know that all routers and firewalls have some mechanism for doing that. Once you understand what you're doing, then it's just a matter of figuring out how to do it. And lots of times you're using some sort of web-based GUI that makes it really easy to drag and drop things and create rules and whatnot. But we're going to be talking about routers. So first thing I want to talk about a little bit about the philosophy of creating access lists. There's two ways that people usually try to route access lists to filter traffic. One way is they try to figure out what is bad and then deny all that, and then they'll permit everything else. So basically they let everything out of the network or everything into the network except for those 20 or 30 things they've decided is bad. So that's generally not the preferred way to do it. The other way to do it is you only let what is needed out of your network and then you deny everything else. And this is the better way to do it, because you're not letting everything in other than what you define as bad, because you're probably not good enough to know everything that's bad. So you should really only let out what is needed out. Specifically for Cisco router access control list, some things we need to understand: we can have standard access lists or extended access lists. Standard access lists match only on source IP address. So it only matches the source of the packet. You can't specify anything else in the packet. Extended access lists can match on many things. Things we'll be matching on: IP addresses, source or destination, source and destination, protocols, ICMP, TCP, UDP, and then we'll be matching on transport layer ports. That's what we're going to be doing. Lists can be named or numbered. If you make a named list, you can use a useful name like inbound traffic. Numbered list, you can put a number on it, and the numbers are special based on whether it's standard or extended. So for example, standard can be like 1 through 99, and extended can be like 100 to, I don't know, some other number. There's a couple different groups of numbers. The access list will either permit or deny the traffic. It should be noted, and I will note it several times throughout this, that every access list has an implicit deny at the end. So if you create a list, anything you don't explicitly permit through that list will get dropped at the end. So if you want to let everything through, then you need to put a IP any permit IP any list line in the list. And then finally, we need to apply the access list to an interface in a direction, and we'll talk about that in a little bit later. So one caveat: methods for writing and editing access control lists on Cisco routers have changed over time. So depending on which version of the operating system you have, you may get differing results. So this first example, I've created a access list that says permit host access list 1 permit host 10.1.1.1. So that list will allow any traffic with a source IP address of 10.1.1.1. The next entry in that list is access list 1 deny host 10.1.1.2. So that's going to drop any traffic from 10.1.1.2. And then I have in the angle brackets implicit deny at the end. So everything that was not permitted is going to get denied. So in reality, that second access list entry of deny was redundant because it's automatically going to get dropped anyway. So that's what that list is going to do. A couple things to point out: an access list can have multiple lines in it. So this says access list 1 and it has 2 lines. Sometimes students get confused and they want to put different numbers. No, you can only apply the interface. You can only apply one access list to an interface in a direction, which we'll talk about later. So if you're creating a list of actions that should apply to a specific interface, then you need to make sure they all have the same number and then they're in the same access list. My next example is a extended access list This is Access List 101. Permit TCP, so this applies to the TCP protocol. Any host, allow traffic from any allow traffic from any to host 192.168.100.10 EQ80. So this is going to let traffic from any source get to this IP address on port 80, which is the web server port. This is another line, similar, except this is 443, which 443 is the HTTPS port for secure traffic. And then we have this next line that says port 53, which is for DNS. So this is going to a different IP address. So this is 100.2, which must be the DNS server for this domain. And we should notice that DNS uses UDP. So you need to make sure you specify the protocol. And then finally, I put another line that says, permit TCP host 100.100.100.2 to host 192.168.100.10 EQ22. So 22 is the SSH port. So basically, I'm letting this particular host SSH into my host for management. So this is what a access list might look like if you're trying to control traffic coming into your network to let your web server work, and if you want to be able to manage your server remotely from this one particular host. And then we have this implicit deny at the end. So anything that wasn't permitted will get dropped. Here's another example. I left my named ACL up there for you to see, but then I wrote that same ACL, my numbered ACL, and I wrote that same ACL as a named ACL using one of the ways you can do that. So I first typed IP access list extended outbound from LAN. So outbound from LAN is the name of the access control list. And then it put me in this access control list configuration mode where I could enter the entries I wanted for my access control list. This first one I forgot the TCP, so that didn't work. I was meant to delete that out, I guess, but forgot. So now permit TCP from 192.168 1.0.0.0.0.255 to any host, to any destination IP address EQ80. So basically I'm letting anything from the network that starts with 192.168.1 get out to a web server. And then I'm also letting them get out to 443, which is HTTPS. And then I'm letting that network get to a specific host for DNS. So I've defined my DNS server as 192.168.2.53, the host IP address of my DNS server. So a couple things to look at in this list. In this list, we are making use of wildcard mask again. And a wildcard mask is a way you can specify network addresses. Hey, check that out. I got a slide. So the wildcard mask is the opposite of the net mask. So the binary bits of the net mask get flipped and then converted to decimal. So if we look, for example, if we have a subnet mask of 255.255.255.0, when we flip those bits, that becomes 0.0.255. So basically, these are all ones, these are all ones, these are all ones, and this is 0. So to flip those, I make these all zeros, these all zeros, these all zeros, and these all ones. Right? So when we convert that back to decimal, then we get 0.0.0.255. The place it gets tricky is when we have a subnet mask that doesn't line up on a byte boundary where the dot is. So we have 255.255.255.128. Then the wildcard mask becomes 0.0.0.127. So if we remember 128 in binary is a 1 followed by 7 zeros, right? So then we flip that 1 to a 0 and flip those 7 zeros to 1s, convert that back to decimal, we get 127. So that's the binary way. The easier way to do it is if you need to figure out what the wildcard mask bits value should be, you take 255, subtract the subnet mask from that, and that gives you the wildcard mask. So in this example, we took 255, we subtracted 128, we got 127. Another example, 255 minus 192 equals 63. So if we have a wildcard mask of 255, 255, 255, 192, then we get a subnet, if we have a subnet mask of 255, 255, 255, 192, we get a wildcard mask of 0.0.0.63. You can't just have any random value you want to stick in there. I mean, the router will let you do it, but you're going to get weird results. The expected values for the wildcard mask will be 255, 127, 63, 31, 15, 7, 3, 1, 0. So if you look, these numbers down here are like the block size minus 1 from our subnetting days, right? Block size of 128. If you have a block size of 128, then you subtract 1 from that, you get a wildcard mask of 127, a block size of 64, you subtract 1, you get a wildcard mask of 63. So maybe that'll help you remember it. And another thing, so far the ones we looked at have all been in the last octet. But if you're working on a byte that's higher up in the order, then your wildcard mask will have some bits in those values. So for example, /22 will have a subnet mask of 255.255.252.0, and that gives us a wildcard mask of 003.255. So same thing. You can do 255 minus 252 gives you 3, and then 255 minus 0 gives you 255. If you write some access lists and you want to show them, you can do show access lists, and that shows you, in this case I have a standard access list called 1. I have an extended access list called 101, numbered 101, and I have an extended access list with a name called outbound from LAN. And you see the entries in each of those access lists. These numbers on the side are sequence numbers that we can use to edit the access list. We'll talk about that in a minute. Another way to see the access list is you can do show run. And if you just want to get to the part where the access list, you can use this pipe character and type begin access list, and that'll take you to the first place it finds access list in your config. That might be a new thing. We haven't talked about that before. So then you can see the access list in their native form in the running config. Editing access lists, there are some ways you can do it, and this is the thing that really changed over time in editing access lists. This is like the most annoying thing to me that I think is fixed in newer versions, but I don't think it's fixed in the version we have in the lab. So basically, I have this access list 101. And I think, oh hey, I want to get rid of this line. I want to get rid of this line for port 80. You say port 80, Rich? That's this www. Yeah. Once you put the list in, it changes some of the numbers to names. So if we look back, let's go back. If we look back, this is the access list I entered, EQ80. But if we go down back over here, when it shows www. It shows you the name it associates with it, which I find that to be a little annoying because if you know me by now, you know I like numbers instead of names. So anyway, that's why that's showing up. It shows you names. You can use the names instead of numbers when you create the list, but I just like numbers better because I know the numbers. I don't always know the names. So anyway, yeah, what was I talking about? Oh yeah, I was over here. Not here. One more. So as we should hopefully remember, most of the time you want to get rid of something in your router config. You put no in front of it. So say I wanted to get rid of this list, access list 101 permit. I want to get rid of that entry. So I put no access list 101 permit, blah, 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 right? And then I do show run, include access list 101. And that should show me the entries in the access list, and nothing comes back. So in some versions of iOS, when you try to delete a single entry of an access list, the whole thing goes away. Like I said, I'm pretty sure newer versions doesn't have that behavior, but enough of the older versions are still around that you should be aware of that. Another way to edit access list is to go into the access list configuration mode like we talked about and use the sequence numbers. So when I do show IP access list, I get these sequence numbers 10, 20, 30, and 40. I want to get rid of line number 30. Say I put the wrong IP address. That should be .2. So I can type IP access list extended 101. Do no 30, that gets rid of line number 30, and then I can add a new list, permit UDP any host 192.168.100.2 EQ53. And if I show my access list again, I have a new line down there that says, oh hey, here's your new line. It's automatically put at the end, and it's automatically given the number 50. All right, one more thing I want to tell you, I didn't demonstrate, I should have. If you want to specify where this line goes, like if I wanted to put it back at 30, I could have put 30 in front of that command. I could have put 30, permit UDP, any, blah, 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 and it would have put that access list back at 30. If you wanted to add a new line between 10 and 20, you could put 15, permit, blah, 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 and that could put the line at 15. So that's probably something I should have demonstrated, but there you have it if you want to experiment with that in the lab. So like I said, there are a lot of different ways we could create and edit access lists. I'm not going to spend all day talking about those. In class this semester, we're going to use the name access lists, and your best bet when you're trying to edit them is using sequence numbers. So type IP access list extended in the name, and then use sequence numbers to edit the list. Applying an access control list. So once we have the list, nothing is actually happening until we put it on an interface in a direction. So in this example, I have applied the interface. I have went into the interface FA01 config mode. I put access group 101 in on the list on that interface, and then I've also put IP access group outbound from LAN out. So thing to remember, these directions are applicable to the interface and the router itself. So in does not mean into your network or out of your network. This means into the interface or out of the interface. So that's what's going to happen. So this first list I put on will be checked for traffic coming into the interface, and this second interface, the second access group I put on there will be for traffic going out of the interface. So you can only apply one ACL per interface per direction. So this is it for access control list on this interface. I can't apply any additional access control lists. Another way to say the same thing is you cannot apply two access control lists to the same interface in the same direction. So I could not have made this in. That would not have worked. Another thing to keep in mind is where you put the rules may change. Where you put the access control list may change the rules you write. If you put your access control list on your network, your LAN interface, but you have a DMZ, you're now going to have to allow the traffic that you need to get to the DMZ or the server network through. But if you put it on the way out of the router, then your traffic, you might not have to filter as much. I think we'll talk about that again in a minute. Be mindful of return traffic. You might inadvertently drop some things that you weren't expecting to drop, and NAT can complicate things. And what do I mean by that? Well, let's talk about NAT first. As we talked about in our NAT slides, this is a server on my network. The NAT address for the server, in this case, we're saying 100.100.100.2. So clients over here that want to get to our server are going to type 100.100.100.2 in their browser. It's going to come to the router. The router is going to translate that and send it to the server. The server is at 192.168.10.2, right? So what happens when it gets to this interface? How do you write your access control list? Well, it depends on what happens first. Does the router perform the NAT first, or does it check the access list first? If it checks the access list first, then you need to use the public IP address, right? If it does the NAT first, then you need to use the private IP address. And this is something you need to figure out for whatever device you're using. You need to figure out the order of operations and where you're filtering. And that's if you're filtering on the outside interface. We know the NAT's going to happen by the time it gets to the inside interface. So if you're filtering on the inside interface, then you can filter for the private IP traffic. But what's the benefit of that? What's the downside of that? Well, then your router's already processed all this traffic that you might end up dropping. Return traffic. So say we put a list on here that says let port 80 traffic out, let port 443 traffic out, and let DNS traffic out, right? We have that on this interface. Well, we're talking about destination port traffic. So if we have traffic that comes from this client to our server, right, this traffic going back out to the other client is not going to match your list because it's going to be a different set of filters needed. So you may need to modify your list to allow that traffic out. And I think that's all I'm going to say about that. So to summarize quickly, access control lists can be standard or extended. They can be named or numbered. We're going to use mostly extended and named in the lab. We will use a standard numbered list for NATs. They will either permit or deny traffic. They need to be applied to an interface in a direction. The easiest way to edit them is using sequence numbers. I didn't have this in there, but we should also remember that there's an implicit deny at the end of every list. So anything that's not explicitly permitted will be dropped. If we need to specify networks, we use Wildcard Masks for that. NAT can make things complicated when you're implementing access control lists. And different versions of the iOS software exhibit different behaviors with regard to access control lists and how they can be created and modified. So you should be aware of that. And that's all I have to say. So same thing. Any questions, put them on the discussion board or bring them to the class and we can talk about them before we start the lab.